All right, we'll get going for the 4 o'clock session. It's the last one. You guys all have to stay awake. You have to promise me. I'll throw some stuff at you.
I'll do my best.
He'll throw stuff at you. Let's just go that. This is the session for reliability for pumps and distribution and treatment plants. And today we have Tom Bingham from Spartan Controls. Tom has accumulated 2 decades of experience at Spartan Controls. His journeys began by constructing electrical and pneumatic panels in the workshop, and looks like he transitioned to electrical design and implementation and commissioning. His responsibilities expanded to encompass project management, and for these initiatives, including some of the natural gas compression, predictive monitoring projects. He presently holds the role as the lead for reliability and predictive maintenance and technical sales. He specializes in aiding customers with design and implementation of condition monitoring solutions in an area that he's honed his expertise over the years. So he's here to talk to you guys today. It's all yours, Tom. Thank you.
Thank you. Can you guys hear me in the back okay? All right, so I guess I don't need to do an intro. Thank you. I cover what they call technical sales within Spartan. So I'm going to go through some examples, some of the learnings that I've had over the years. It is specific to pumps, but it could be applied to many different types of assets as well. So if you want to break it down, and I'll try not to read this slide, this will be the only one that I might have to read a little bit on, but your unreliable assets have enormous consequences. So most machines get pushed year by year more and more above what their capacity would normally be. The average facility would probably spend about 5% of its replacement asset value on maintenance each year. And in comparison, some of the best performers out there would spend about 2% of that with enjoying more uptime. So I'm going to talk about a few different ideas and solutions around pushing yourself into that. And then the big one too, and I'm more focused on vibration, so I'm biased in that regard, but vibration events develop slowly. And they can be monitored because in the end, they escalate quickly and you don't give you much time to respond to it. So I'm going to talk about some techniques to see that earlier on. So with my role, I work with different customers doing walk downs and site visits to help them spec out what they need for a monitoring technology. I focus on rotating assets. Today I'm going to focus more on pumps, but we want to move our customers from that equipment failure where they may not have any monitoring or limited monitoring and work up. So meaning that, you know, if you have your failure curve here and you have your cost to repair here on the bottom, some folks may have maybe a limited vibration or basic vibration on machines, maybe some temperature monitoring. We want to focus more on that vibration analysis and predictive analytics, where it makes sense, of course. So another way to look at that would be some of the older vehicles would have maybe simply a check engine light. And with that, you don't really know what's going on. You just know that there could be a potential problem. It may be failing already. It may not be it may not be predictive or advanced enough to give you that window. With some of the new BMWs, for example, they have a predictive maintenance program. They gather history on the drivetrain and so on, and they collect that and use that for a better predictive maintenance program with that vehicle. So if we look at this treatment facility here, there are many different types of assets. You have your pumps, compressors, agitators, and so on. I mean, specifically the pumps themselves, they're a pretty common asset amongst many different industries. There are quite a few different pumps here, that's for sure. So what are essential assets? Most people are monitoring their critical machines. They have some sort of shutdown system on there. But when it comes to essential and important, the machines I talked about earlier on, like the pumps and compressors and centrifuge, those types of things, they may not have any monitoring at all. And that could be nothing as in regards to like no route collection, or maybe they have some route collection but no continuous monitoring. We're looking to push that envelope a little bit more so that customers are open to that type of monitoring. And the reason for that is if you have multiple process pumps within your facility, maybe 10% would have that type of monitoring. But of those, 100%, if you look at the full gamut of pumps that you have in the facility, 40% of those could be considered critical. So you have a large percentage there that aren't monitored at all, but they're still critical within your facility. So another way to look at this would be your quartiles, like top quartile companies and how they run and function. Some of the top items that they have, let's say vibration, oil analysis, NDT, much higher percentage of machines they're monitoring with this type of solutions, I guess. Another thing to keep in mind too that's interesting is the amount of bill of materials created on their machines. So what I mean by that is the list of parts required and the steps to make those changes on those machines is much higher in those facilities. So they have less preventative maintenance and higher bill of materials for the maintenance when it is required. So what I'm trying to say is that they have these sensors on the machines and they're seeing them start to fail earlier on, and they can plan it with the right steps to do that. And if you have any questions, feel free to interrupt me as we go along here. I should have enough time to go through it. All right, if you look at the anatomy of a pump failure. So something to note here on the bottom is the undetected zone. So as a pump starts to fail, it may not have any symptoms that you can see, depending on the technology you're using for sensing that. So if you think of a mechanical type of failure, it may be due to a bad installation, so a shaft misalignment on that drive to pump, or bearing wear within it as well. This will cause some excess vibration. But there's also other things too in regards to process. Restricted discharge, suction, that type of thing as well. All of these will lead to different type of events that may not be detectable at that level. It's not till this stage that you would see the failure coming through seals, bearings, mechanical type of events, an imbalance or misalignment. A lot of those are actually detectable with the vibration sensor. And then as they start to fail harder, they start to cause bigger problems, that's for sure. So the benefits of monitoring these pumps is that you could you could be able to see this so you prevent cavitation. That's a big one. Getting some of these early warnings so that you can plan and replace the bearings, or if there is a gear drive, that type of thing. And of course, environmental hazards and concerns. Downtime is a big one as well. So when I say continuous versus manual monitoring, maybe hands up. Do you guys understand what I mean by that? Just a simple question. Does it make sense, route versus continuous monitoring? Okay. So as a particular machine is running, let's say you gather data on it monthly. If that machine starts to fail, there could be a giant window in there where it seemed to be okay versus it's very bad. And it seems like common sense, but I think this is a good slide to represent the fact that the route collection may not be enough, depending on the machine. It provides a very detailed analysis at that time with a very large window in between. So why now? So with the technologies that are available now, it's becoming more and more competitive. There's lots of options with wireless, with batteries that last 3 to 5 years versus a few months. And they can collect 3 axes of vibration, temperature, and so on. They're much more cost effective than they used to be. And I have some examples on just how that infrastructure is set up in later slides as well. With the wireless specifically as well, you can significantly reduce your wiring costs and work around different walls and through tunnels and underground and so on as well. And with the system that we have, it can integrate into a DCS or control system as well. It's not cloud-based, so you would own the data. So the different tiers of condition monitoring. So back to that failure curve I had shown earlier on. You could simply not monitor, and over time, your machine would fail. Seems easy enough to understand. So you do nothing. The next one of that curve would be what I call overall vibration. So what that is a sensor that feeds directly into a control system. And what that sensor is doing is it's taking a vibration signal and averaging the whole thing. So it's looking at your low, your mid, and your high frequency data and just averaging that. So it can pick up if that machine is shaking across the floor, but it can't pick up if it has a bearing failure because it's very low amplitude, high frequency event. And you don't have to understand vibration analysis. I won't get into that, but it doesn't, what I'm trying to say is it doesn't provide a lot of data or early indication. The next would be your route vibration collection. Very good data collection at the time, but you have a big window of when a machine can fail in between that. And then online monitoring is either a wired or a wireless. And the wireless sensors actually have a couple here. I'll pass around. This is what they look like. This is an Emerson version. Here, I'll put this one over here. And then the next level I wanted to mention is something called predictive analytics, or you could use other buzzwords, machine learning, and so on. The idea behind this is it takes some of the process data as well as your condition monitoring data, which I mean condition monitoring would be like vibration data, putting them together to see if you can correlate even more failure types. So my job would be moving customers from that manual monitoring, mostly manual monitoring with some continuous monitoring on critical machines, to a asset, like an overall asset monitoring strategy, which would involve more essential machines that have that type of monitoring, continuous monitoring as well. And the idea being that if a flag or an issue pops up on these machines, you would do your routes on exception versus on inspection on schedule basis. We would call this digital transformation, another keyword, buzzword, and so on, but this is a slide that we use for some of those presentations. So just back to machinery health, some of the basics, similar to diagnosing people. There are different ways you can look into it. You have your vibration, your pulse of the machine. Oil is the lifeblood, and of course thermography would be taking your temperature. Pretty basic stuff. So with a vibration sensor, it's collecting what we call a waveform. And with the waveform, there's a bunch of different data inside of that. Now with this, if it's going to feed directly to a control system, a lot of this rich data is just simplified. So what we try and do is take that data. So let's say we have a pump here, and it's got many veins inside, 11 veins, and it's driven by a motor. So with that, there's a bunch of different waveforms that are gathered. Without getting into the details, all of these will be overlapped so that it's one waveform. But you can see in here that there's a bunch of different information. So every time that those veins go by in the pump, there's this many, 11 pulses per 360 degrees. With the Emerson system that I sell, that has something called peak view as well. And what it's doing is taking that waveform and scanning it at 102,000 times per second. So it seems crazy, but the idea behind that is it's logging mechanical impacting within that machine as a separate output. So you have your vibration, and you also have something called peak view. And what it does with that signal is it processes it so that it can differentiate between a lubrication problem or a mechanical problem. And I can cover the details if you guys are interested over a beer or something like that. But I'll leave it at that. And a simple way to look at this is that it allows you to watch your bearing life on your machine and compare it against your vibration that you're collecting. And the peak view, the data processing that's going on in the sensor, gives you an earlier indication based on impacting that is happening in that machine, separate from the overall vibration. So an easy way to think of this, and I have two analogies, this is one. You're standing on the beach, the waves are crashing, and you see somebody swimming out there, way out beyond the waves crashing. What we're trying to do is filter out all the low frequency waves and focus in on that type of frequency, a fault frequency. And that would be, for example, a swimmer, or you take a rock and you whip it out over the waves and you have a little ripple. That's what we're looking for. That's what we're doing with the sensor. Another example I brought up would be, if you guys have kids, young kids, you show up at the daycare, the door's closed, there's kids freaking out inside, and you can pick out your kid based on the frequency of their cry. Been there, done that. So we talked about vibration a little bit, some of the basics. So there's a bunch of different fault conditions that are detectable in machines. And the fault conditions would be listed here on the left, for example. And the different types of sensing techniques are on the top. So we try to work with customers on, maybe they have some existing sensing already, and they just need to overlay a few others to help enrich the data. But this is just a sales slide to kind of give you an idea of the fault conditions detectable. So another example of that is you got your motor and pump. Oops. And they have motor current available already, density and discharge pressure, which is good. They have some sensing on there. What we would do is look at that fault conditions chart I had talked about earlier on the earlier slide, and we have a bunch of different ones based on different models of pumps. And we'd possibly recommend look at adding vibration and temperature on the pump and the motor. And you can do that with those wireless sensors, and I have something called an asset monitor, which is a wired unit outside as well. Both would work in a similar fashion. So with the wireless, the way it works is it would use a gateway, and this gateway is a wireless antenna that gathers all the data. And you can add in your sensors at particular locations on the machine with about 100 meters between the sensor and the antenna. And the way it works is it creates a wireless mesh, and the mesh is automatically connecting the sensors based on to their locations, and they would work the data back to the antenna. So for example, if I have a vibration sensor here, the way it would work is it would jump it to the pressure gauge that's wireless and back to the gateway antenna. And then from here, there are a few options. You can feed it to analysis software, or you could bring it to your historian or control system. It doesn't need to be ours. It works on universal protocols like Modbus and OPC. So that's the wireless solution. The other option that we offer is something called the asset monitor, and it's a wired unit, 12 channel, and this would usually sit right on the machine itself, and you can bring in more than vibration, speed, temperature, pressures, and you can bring that all in, and it allows you to actually build a template within the box. And what I mean by that is it'll collect your data, that, vibration or whatever it may be. It'll do data processing inside of the box, and then it'll set up these analytics from the box as well that'll give you what I talked about peak view earlier on, your bearing health, your lubrication, looseness, that type of thing, high pressure, temperature, depending on what you have fed into it. All of this is available right from the box, and it could be fed to a control system as well. So it's doing that data processing that would be your initial vibration analyst type of thing. Not to replace that person, of course, but just give them the next step up. So here's an example of if you logged into that box, you see the same data here. These are the measurement points that are being fed into it. You have a trend of the overall health, and then any alerts that are coming through on that particular pump. If you have multitude of pumps or machines that you need to feed into one central software, we offer something called MachineWorks. It's not a requirement, but it's an option. And this allows you to see the health of your machines, your bearings, with easy to read colors based on health. You can see the overall measurement status. You have a communication window here as well, and there's also detailed fault analysis and vibration, which I won't get into, but all of that is available in this tool as well. The other option that we have is more of an advanced service offering. So trouble machines that you guys may have on site, having a hard time trying to figure out what the exact problem is. We can do a one-time or a multitude of visits based on that machine. So this is a low frequency analysis. It's called motion amplification. And what it's doing is, like I say, it's just amplifying the motion of the machine, trying to figure out issues that you may be having with mounting feet or movement within the machine, misalignment, looseness, that type of thing. This is a good tool for that. Opens the window into that vibration analysis. This is another way of viewing that as well. A real picture, but it's amplifying the motion of that machine. It's a reciprocating compressor. So I do have a few case studies and examples from different customer sites. A lot of times they'll have a machine that's going sideways on them, and they don't necessarily want to go with a wireless yet or a wired unit. They just want to see what the issue is. So we had sent one of our service technicians out. These were two wastewater treatment pumps in series. So they were in parallel, but two would feed two, if that makes sense. So this one here, which is just out of the picture, would feed this one, and then there would be a few hundred meters of line after that. So they had a bearing failure that cost them close to $100,000. They didn't see it coming, and they were looking for a way to see that, have a predictive window in the future, of course. So we had sent a technician out. He used his route analyzer, and with the route analyzer, he could see a few things. So one of them was that the first pump was feeding the second pump, and when it was starving the second pump slightly, and we were seeing this modulation in the frequency. So it was this weird speed up, speed down situation where we would see a vane pass, which was leading to a mechanical looseness in the pump. So a lot of that you can't see without vibration, and it was a good tool to monitor, not necessarily react right away, but it gives them a window into, okay, we have a potential situation based on process control, and it's leading to a mechanical type of failure. So it's something to monitor long-term, plan for the future. And this is just a picture of that bearing there. You can see the outer race has got a bit of scarring on it. Another example here, no failure, but they were looking to modernize on their monitoring. So this particular situation, pumps were fed into the asset monitors, the wired unit, and these are right on the base floor. So these are the pumps here. If you turned around, this would be the panel. And within the panel, they had 24 channels set up to bring in vibration from those pumps. This one's in my territory. I'm from Calgary, so they had some centrifuges that they were looking to monitor. They had some major failures on these. Struvite buildup, so when they build up inside of that centrifuge, they have a ton of imbalance, and the imbalance will shake those things apart. So they wanted a simple way to collect that vibration, and it's very easily detectable with most vibration sensors. It's actually on the lower frequency side. So this is the system. It's mounted right next to the machine. Saves on wiring costs because you just have to bring a communication wire to this. And then they actually fed it into their Pi system where they could see a lot of that data and trend it long term. Another example is on a clarifier. With a clarifier, what makes it complicated is that it's very slow speed. So with slow speed, you need to collect a very long waveform. Without getting to the details is the best way to do the analysis on it. So with this box, not the wireless, this one is probably the best solution. And it allows customers to monitor the two drives, two gearboxes, and then the pinion and bearing that goes down into the center of the clarifier. And then this is an interesting one as well, where it was a mobile unit with the asset monitor. And they were feeding more than vibration. They had pressure, temperature, pressure again, and then they had a thermal camera that fed into that as well. And this was a pretty cool idea to troubleshoot machines on this particular site. All right, so I do have a quick video I wanted to show, but maybe I'll come back to this after. I do have time for it, so we should be good. All right. All right, so this is a reciprocating compressor. So with a reciprocating compressor, you can monitor just the basic vibration if you'd like. And the sensors would go right on the machine, and it's pretty common. A lot of packagers use this to monitor their machines, and it's kind of like a basic, hey, we're doing vibration collection, we should be fine. The problem with this is that with just those sensors, they don't see a lot of data when you're thinking of predictive maintenance on the machine. So what we recommend in those cases is now monitoring the cylinder head vibration, cylinder pressure, and rod position. And the reason for that, as you'll see here in a minute, is that as this machine starts to fail, you can see rod position is starting to go out of whack, and that's your piston rod going back and forth. You can see your cylinder head, so these are the valves on the cylinder, are all out of sync, and they're starting to get louder and louder. But on the bottom here, you're really not getting any sort of indication on your overall vibration of that compressor. This machine starts to fail more and more and more. The piston's actually going back and forth at an extreme rate where the rod position is out of whack. And this guy right here is still not seeing any sort of indication of failure. So I wanted to highlight this, and I've done this a few times, where you can really start to pick this up earlier on with the right type of monitoring. But with the wrong type, it's really not providing much value until the very end when you see this compressor fail. Right there, yeah. Yeah, so. So in conclusion, the challenge is planning your maintenance at the right time. You can continue to do it on a scheduled basis, or you could use a tool that'll help you plan that so that you can stretch that out as you need to. We have a few options. I talked about some of the sensors that hopefully I'll get back after. And then we also offer some digital infrastructure solutions for cellular modems, cloud hosting software. Most of these are used for a pilot program to get the customer started to avoid their IT hurdles. And then from there, they can integrate that data into their system long-term once they expand. And then we also have some analysis. We have service support. We send guys all over our territory, which is Western Canada, to support customers either on demand, scheduled, or embedded. I don't think I have anything else to share, and I actually rolled through that a little quicker than I was hoping, but that's okay. It's the last presentation, so I figured you guys would appreciate that. Please, if you have any questions, reach out. And I'm using this one for questions, I'm assuming, right?
Is there any questions for you guys out there?
I didn't put anybody to sleep, I don't think.
Yeah, and then I'll send you out there.
Okay.
Any questions? Aaron, is there anything online?
No? Okay.
Last chance, no questions.
Yeah?
Attaboy, Jamie. Go for it.
Is there any plans on using AI to monitor the analysis?
Good question. Can I talk here, or this thing yell at me? Okay. Yes, we offer a solution. It's through Aspen Tech. It's a company that Emerson's just purchased. So the way it works is they'll gather up to 2 years or more history, so work orders, trending, process data, and then overlay it with the vibration data, and that's the solution that we could offer. There's lots of options out there right now, so we realize that. So with our technologies, you can also feed it to something else as well, like a historian, and then pull that data out and do your machine learning. Any other questions? Yeah.
Thanks, Tom.
Thank you, guys.